So, welcome to a minor delayed lecture due to some technical issues, but now we are live and you can see me the first time now. Sorry that I couldn't make it last week. We'll do most of the lectures now together with Anand. Last week we had the organizational aspects for both courses. First, emerging technology for the circular economy course that is specifically tailored to master's students in the digital technologies master's program and the computer science people, but also some other people can just voluntarily take this course. And then the other half of our audience being the mining students who do a course whose name I'm always forgetting. It's something with circular economy and IoT, something like that. So for the first few lectures, as Anand and Chintan explained last week, we'll do this course together. Then at some point, the mining students going to branch off into a separate track with more mining-focused aspects, while the computer science or digital technology students will do some practical coding case studies with us. And then at the end, we'll come all back together for the last and final lecture provided by Anand. And yeah, that's the long story. Today, we'll do an introduction session. We'll first look a little bit on the motivation. Why should we even bother to look into this topic? Why should we think about emerging technologies or digital technologies in the context of sustainability, or more precisely, the circular economy? And then we'll already start in the second half of this lecture by looking into the first linear economy and then a brief glimpse at the circular economy, so that we at least get one part of the lecture's name straight, like what is the circular economy, or what's the linear economy, what's the problem of this linear economy, so that we need a circular economy. Anand is going to pull up a poll in a second. Then we'll just do it without the poll and wait for you to write something in the chat. Because for us, an extremely important question is, would you like to do this lecture actually just live in a stream, or are you just watching the recordings, or are you really interested in joining us on a regular basis? Because for us, it's like a little bit of technical effort and also time investment to be here. And today we have a whooping audience of 0 people here in Goslar. That might just be a one-off. Maybe usually we have 20 people here, maybe not. So I'll like to give you now a few seconds to think about it, whether we should continue offering this live presence in Goslar, which also means that please people show up. Or do you prefer to do this as a constant online lecture where you have the weekly live stream for the lecture and the Q&A, as well as the recordings for the lecture? We do not record the Q&A for privacy reasons, so that everyone can really ask questions. And yeah, would be really interested in your thoughts. So take, 10, 15 seconds. Think about, do you want to come here on a weekly basis, and are you really going to follow through with it? Or do you prefer a completely online lecture format? To make it simple, I would say there is the poll. So first option, yes. Do you want to attend the course in Goslar? Click yes. If you're fine with an online format, then please click no. You have 10, 15 seconds to consider. And then we're going to move on to the actual content of this lecture. By the way, for us, both options are fine. You do not get any brownie points if you vote yes or no. So the most people would like to do it online. How many? I cannot really see the count here. How many people said? So one person. Okay. How many people do we have online? 25 out of including. Okay, so out of 100 students. Okay, Anand and I will get together after the lecture, and then we'll let you all know what we do with this voting result. But thank you very much for participating. And now we're going to come to the actual lecture content. So whenever you are tasked to deal or to get yourself into a new topic or to learn something new, it's always helpful to have a motivation on why you're supposed to do that. Sure, there are various courses that you have to do. I hope this is not one of them. That's why I'm trying to give you a really good motivation for this course. And other courses you're doing because you like it, you're interested, or you see a deeper meaning in it, or that you can see, okay, this has a profound impact on my life. And our goal is for you to understand that various parts of this course actually will have or will deal with problems that you as the next generation, and we obviously also, have to solve so that you even have a future. I know that every professor says, my course is the most important. You should ignore all others, but mine is the most important. I'm not going to say that, but I'm going to say that the topics that we're dealing here with are among the most pressing issues that will follow you through, for the rest of your life, and also will have a tremendous impact on the quality of your future life. And we're going to go back quite a bit to start this journey to make this point of why some of this content belongs to the most relevant problems you will ever have to tackle. And this is actually a book. Unfortunately, I only have the German version myself to take a picture of, but this is essentially the book that this whole topic started with for myself personally. The English title is The Limits to Growth, or in German, Die Grenzen des Wachstums. It is a book that is super old now, 55 or almost 55 years now, but still talks about topics that are relevant to this day. And it's a quite short book, you can easily read it, but the interesting point of this book is that it, back in the 1970s, asks the question, what can a finite system with limited resources offer? And please keep in mind that back in the 1960s, 1970s, the computing power of the fastest computers in the world, even those like existed in a very limited space, was probably nothing comparable to the smartwatch I'm wearing right now. So we're talking about a lot of math that could be slowly adapted and solved via computers, but with extremely limited computing power. So these models that we're now talking about, they have some limitations, but given those constraints that they had back then, it's quite interesting and not amazing, but impressing what they figured out there. So that was the forward essentially for this book. What is this book actually looking at? So the book is based on this question, or is tackling this question of, given our planet that we have, which is a finite planet which has finite resources, being it, for example, air, water, resources like coal, gold, whatever, how many people can it support? And what happens if we consume resources at a certain pace? How long can this go on without anything going wrong? You can think about your bank account as an analogy. You have a certain amount of money in your bank account, and depending on how much you spend, you run out of money or you don't run out of money. For the whole world, this is slightly more complex because you have way more variables. You have to somehow account for all the resources you have. You have to somehow account for the consumption of resources. Then there are other side effects that you have to think about, like environmental pollution, how many people you have, how big the industry of certain parts of the population are, and so on and so on. And this book, The Limits to Growth, tried to model those aspects in a, back then, super complicated way. Nowadays, you would say it's rather simple, but still quite expressive. And it used those 5 main modeling parameters that we're looking here in this graph. So we have on one hand resources, which is a catch-all category for all resources. So it encompasses water, materials that you can mine, and so on and so on, which is indicated here in red. You have a population with black. You have the food per capita, so how much food per person can I produce and can I consume. You have the industrial output per capita, so how much do we produce per person, and then you have the environmental pollution. And they started out in their modeling with the base assumption of how many resources are there, how many can we consume, and then they also modeled some equations to predict how, for example, the resource consumption is developing given, for example, a certain amount of students, not students, sorry, people living on this planet there. So the more people you have, the more resources you consume, and so on. And then they started their model in the 1900s. And since this book was published in 1972, the work happened a few years earlier. They already had something like 60 to 70 years of historic information, which they could then compare their model to. So from 1900 to 1970, they could see, okay, does this roughly fit? And everything afterwards is then a prediction, and the model runs until 2100. So there are various, and we'll get back to that, I think, at some point in this lecture. There are various different models that they created and different simulation runs based on different assumptions. So how many resources do you have? How fast are we developing technologies that help us, for example, to prevent environmental pollution, and so on and so on. But the model that is mostly used and most helpful to get this main idea and also to get back to our motivation is a so-called standard run, the World 3 standard one. World 3 is the model, that's the name of the model, and standard run is then the most commonly used simulation that you're looking at right now. So in the 1900s, it starts with quite a huge amount of resources and rather low population count, low industrial output per capita, mid-sized food per capita, and almost no environmental pollution. So we're here roughly 50 years into the Industrial Revolution at this point. And what happened starting from the 1900s then to the 2000s is we had a tremendous increase in the population. So we went from just a few billions to now, what is it, like 8 or almost 8.5 billion, not quite sure. So we had tremendous growth in population. We also increased mostly, and on average on this planet, our living standards heavily, which means more food per capita, higher industrial output per capita, which then uses a lot of the resources, and so on and so on. So you can see that the amount of resources that we have drops quite drastically, while food per capita, industrial output per capita, and population go up heavily. What also slowly but surely starts to take off is the pollution. Now, the really interesting part, which brings us back to our motivation, is that you can see that there are peaks for food per capita, industrial output per capita, population, and pollution. After those peaks, there is a tremendous drop. And you can probably best illustrate why this drop is concerning by thinking about this in terms of population. There is a significant reduction in population, which might not really concern you by just looking at this figure, but it essentially means billions of dead people, because this system seems to run into some kind of trouble at some point. Because growing population, which uses a finite set of resources without any constraints and not caring about the pollution that it puts in the environment, seems to make the system crash heavily. So you can see that the industrial output almost drops to zero by the end of this century. You can see that the food per capita goes down even below levels of the Industrial Revolution. You can also see that the population somehow goes down by a few billion people, and that we have quite few resources left by the end of the century. So this seems to be some kind of a problem. And sure, this is just a model, this is just a simulation, but it was personally for me, when I first read this book like 20 years ago or so, a quite interesting thing because no one seemed to talk about it. And also it rose, like for me, it raised the question, what are we going to do about this? Because at the moment, it doesn't really seem like anyone cares about saving quite a lot of resources. No one really does tremendous efforts to prevent environmental pollution. And no one somehow prepares for the fact that we will run into these resource scarcity problems. And this essentially led then for me to this journey of trying to figure out, okay, what can we do? How serious is this problem? Because there's one big issue with this model. It gives you a time frame, but it is not time sensitive in the way that it precisely predicts or even attempts to predict. It cannot precisely or cannot at all predict when certain events occur. It gives you a tendency that towards the end of the century or somewhere in the second half of the century, we'll run into serious problems. It does not tell you that on the 16th of March 2060, 5 billion people die. This is not the point of this model, and it's also, of course, not within the computing capacity and within the modeling capacities of the 1970s. So what's the main takeaway here? It is supposed to get you started on this idea or this mindset that in a finite system, you cannot have infinite growth and infinite resource consumption. If you have a finite set of resources, you will run out of resources at some point. No matter what technologies you're going to develop, no matter what kind of magic you're trying to do. If it's finite, it's finite. It's not going to quadruple or anything. Last note on this model, there are actually also simulation runs for this model where they assume, okay, what if we have twice as many resources, or what if we have unlimited resources? That should solve our problems. Those model predictions also end more or less in the same way, because just having unlimited resources lets the population grow even harder, food per capita goes up, industrial output goes up, and the pollution goes through the roof, and we're all dying of environmental pollution. So we put the link or the book as a reference to this lecture series there. You can download it for free. It's quite short. It's easy to read. There are also websites where you can play with the actual simulation and move some of those numbers up and down and then see what happens. Highly recommended, quite insightful and really interesting. If you're interested in more details just about this model, we can put up a link, or you can find our Limits to Growth lecture series for the bachelor students on YouTube, where we have a whole lecture, not a whole lecture series, but one like lecture part just dedicated to the World 3 model. I think you will find, and Anand can probably put it in the notes, our ltg.etce-lab.de website, where you can find the video on that. Moving on, there's also a link in the lectures where you can play with the demo, but we're gonna move on now. So 1972, book came out first time. What happened afterwards? They published a few updates. The most notable one, the 30-year update in 2004, when they looked back, okay, how well did our model now match what happened between 1972 and 2004? So they had the data for 1900 to 1972, because that was historic data. But what happened now with those 30 years that it predicted? Was it perfectly fine? Was it way off? Because you would hope that it's very much off and that everything went much better, much smoother than expected due to tremendous technological developments, or we find new resources, and so on and so on. The problem is, nope, it was very much on course and we're heading towards disaster. So not really any relief in sight. And there are those people, like the Club of Rome, who wrote this report, are not really the only people who are warning that we're running into issues here. There are very much different approaches to visualize this overconsumption of our natural environment in different ways. Something that you might have heard of or read about in the newspapers, because it pops up more or less every year, usually around May, June, July, August. at times in the newspapers, and then you can see, okay, we used all the resources for this year. Obviously, there are still resources in the ground, but it often pertains to this concept of the so-called Earth overshoot day. The idea is quite simple. If we have a finite planet with some resources that cannot be regenerated or not being regenerated in a meaningful time, like we can produce new oil on this planet by mimicking the same process how the first part of like amount of oil came into place, but it's not relevant for our lifespan. And then there are resources like, I don't know, growing timber, for example, that move much faster, or growing certain amounts of food. So some resources can be regenerated in a meaningful amount of time for us. So you have a finite set of resources that you cannot regenerate, and you have a set of resources that you can regenerate. So within this context, you have a certain limit of resources that you can use per year without over-consuming, for example, certain amounts of resources. So if you harvest all the wood in any given forest, then there is no wood for the next, or no timber for the next year to be harvested. And it's not going to regenerate really fast. If you're over-consuming any other resources, you might run out of those in the same manner. So you have to find a balance between consuming and regenerating. Usually you should either consume less or exactly the same amount of than the one that is regenerated. So if I get 10 cubic meters of timber from one piece of forest every year, because this is exactly the same amount that it regrows every year, then I'm even, then I'm in a nice equilibrium. If I'm using more, then at some point the forest will be gone. This is, for example, what happened in England or UK in general. They had vast amount of forest. They used it mostly for building ships and the Industrial Revolution. Now there's quite a lot of forest gone. Same is true for large parts of Europe. There was once the saying, probably an exaggeration, but the saying that like a squirrel could jump from England to, I think, the south of Spain or something like that without ever touching the ground, because there was just so much forest. That is absolutely not the case anymore. So back to the actual topic, Earth Overshoot Day. So how many resources can I use per year as a society on this planet without over-consuming? You can think about it once again like this analogy for your bank account. You have a certain amount of money that you get every month or per year. How much can you then spend any given day or any given month without running out of money? And the Earth Overshoot Day is that day where we used up the budget for this year. And initially, when they started this in the 1970s, you can see there's the biggest part of this pile is green, which is good, and only a small portion of this bar is red. Red is when we over-consumed. Those are the days where we used more of our planet than it would be sustainable. And you can also see that the red part tremendously grew over the last few decades. And nowadays, somewhere around July, we run out of resource budget for this year. And if you translate this now, we're using 1.8 planet Earth per year, despite the fact that we only have one planet Earth. So we would need twice the amount of planets to continue doing what we're doing, which will lead to disaster. And you can see the problem here. If you're overusing, if you go back to your bank account, if you're spending money, like your whole annual budget, your whole annual salary, just assume you get it paid on the 1st of January, and then you have to live with that money for 12 months. If you're broke by the end of July, and August, September, October, November, and December, you have to live on credit. Do that same thing again next year, then live another 5 months on credit. You will run out of money. No one will give you money if you're spending 1.8 times your salary per year. You can do that maybe once or twice if you're really lucky, but this is just not something that will continue to go on for a long time. And you can explain this really simple even to children, but somehow no one really cares, and we're just doing what we're doing. there are different aspects to this problem, because the World 3 model, with its 5 parameters that are shown in this figure, also the Earth overshoot day, they're obviously trying to simplify an extremely complex aspect or complex set of problems that somehow then lead to those cluster of problems that we're talking about. As part of this lecture series, we want to look at 3 of those clusters of problems in more detail. You can also call them 3 main challenges of the 21st century, I think is what we're usually going to refer to them. Those are not the only challenges, obviously, for the 21st century, but they are among the 3 most pressing challenges. If we don't figure those out, then it doesn't really matter how rich and how successful you are, then you're going to have a shitty life at some point in the near future. So the first challenge that we're going to look at is environmental pollution, which is going to be one of the stronger motivators for the circular economy later in the second half of this lecture. Because the truth is, we are very shitty at managing the waste that we're having. So the first picture on the left is from Greenland, if I'm not mistaken. Yeah, it's in Upper Narvik, where it was not until very long ago that the preferred method of disposing of municipal waste was to back up a semi-truck to a cliff, unload that truck into the fjord, and then just say, okay, it's gone. I can't see that waste anymore. It's not my problem anymore. The second picture on the right, also probably a quite familiar picture from documentaries or from news articles, that especially Western countries like the US or also Europe in large scale have a tendency to just ship their waste somewhere else, specifically to more poor countries, thereby trying to circumvent their tremendous waste problem. So if it's just pushing it somewhere where it's not my problem anymore, even though this is also extremely short-sighted, because at some point the environmental pollution that you cause somewhere else is going to bite you in the ass in the long run. So at the moment, our preferred method of getting rid of waste is just somewhere else, but not in my front yard. And environmental pollution is not just the waste that you might have in your trash bin. That's just one type of pollution, of environmental pollution. This is a solid stuff that you throw somewhere, like those nice plastic bottles here. There's also environmental pollution, for example, of the air, where we do not really export our waste, but where we're also because it's not visible, you can't see it anymore, we quite do some damage that we're then trying to ignore. Fossil energies being one of the main drivers of environmental air pollution, for example. Coal plants being among the main contributors here. And despite the promises of countries like Germany's in the past that we're going to become a green and sustainable country, we're still operating some of the most dirty coal plants on this planet, or in the European Union at least. So 3 of the 10 dirtiest coal plants are located in Poland. The other 7 are located in Germany, which often prides themselves in being one of these leaders of the sustainability revolution, or trying to become a green and CO2 neutral country. But at the moment, we're extremely far away, especially by this goal of being 100% renewable by 2030. We're so far away from that goal, that's not even worth discussing the probability of that event happening within the next 4 years or 3.5 years by now. There are also other types of pollutions like water pollution, soil pollution, and so on, but we'll get back to that topic a little bit later. This is supposed to be the teaser session, so environmental pollution being one of the main problems. What you now see is that those problems are also not just distinct problems that you can tackle separately, or that you can look at from just one single perspective and then see them as one isolated thing. Because if you go back to this air pollution, for example, by burning fossil fuels. They're like getting pollutants into the air that are, for example, bad for the environment or bad for your health, but it also emits greenhouse gases. We'll discuss like the exact definitions of greenhouse gases in later parts of this series, but greenhouse gases like CO2 have the tendency or have an effect on the climate that we're living in. They are one of the main drivers of the global warming, which increases the global surface temperature. So the more fossil fuels you burn, the more CO2 you emit, contributes to global warming, to the greenhouse gas effect, thereby changing the climate on our planet. So the more coal, the more fossil fuels we burn, the hotter our climate becomes. And that leads us to the second cluster of challenges, which is related to the first one, of climate change. You probably are familiar from the news with this goal of limiting climate change to 1.5 degrees Celsius, so that we're trying to stop global warming of 1.5 degrees. The bad news is that goal is already gone. There is no way that we keep 1.5 degrees. Because we've just emitted too many CO2 emissions. Even if we stop today, whole planet, no CO2 emissions anymore, we're still going to cross 1.5 degrees because there are some delay effects in our atmosphere. We're definitely going to hit 1.5 degrees. So what's the next threshold? 1.6, 1.7, 1.8, something like that maybe. That depends on how long we're going to continue pushing out those greenhouse gases which feed the greenhouse effect, thereby warming our planet. And depending on how well we're doing and some other external factors, because once again, it's an extremely complex system that we're trying to model and predict here, we have different predictions, warming predictions for the remainder of the century. And if you look at this graph here, you can see on the left side the global greenhouse gas emissions in gigatons per year, that in gigatons of CO2 per year that we are emitting. And then the graphs indicate, okay, if we adapt those policies and take those actions, then X, Y, and that happens, and then we get to this graph, and so on and so on. So the bottom line is essentially the 1.5 degrees, the 1.3 degrees to 1.5 degrees global warming goal, which is already gone. So just before we can see the 2030 there, around 25, 26, we would have needed a tremendous drop in greenhouse gas emissions, which did not happen at all. So what would be the next goal? Let's say we do something, we try to limit it to 1.8, that would still require a significant drop in those emissions by 2030. And at the moment, we're not really on the way to go there. Which is even more concerning is that those pledges and targets that big nations put out as big promises to do something, mostly with a promise of limiting global warming to 1.5 degrees, if you even take into account that they are fulfilling those pledges and that they're trying to keep those targets, which they not do at the moment, even then you're just ending up with 2.1 degree global warming. So they're promising to do something to keep 1.5 degree, but what they're promising only gets us to 2.1, and they are not even following through with those promises. So at the moment, we're not even making it to 2.1 degrees. And then the other predictions are essentially for other worst case scenarios. If you're more interested in this, I also recommend you the Limits to Growth lecture. There's one serious part where we're going into extreme amount of details with regards to that. So, not really great news. What I do not have here as a slide, but which is also part of our other course, is that there's obviously also an upper threshold of global warming that we can take. So we know it's not going to be 1.5 because we already crossed that level. But what's the upper threshold, the upper limit that allows us to survive on this planet. The problem is there's not really any precise and good number, because this is really hard to model and to predict, and most researchers are quite hesitant to put out a number, because it's really complicated to come up with a proper number that you can justify, and it's also fucking scary. But there are some estimates that around 3 degrees, 2.7 to 3 degrees, we're running into serious problems that would be so severe that not everyone on this planet dies, but society, as it exists today, would probably collapse. So somewhere between 1.5 and 3 degrees, we're running into such big problems that you probably don't have to worry about the new iPhone anymore, or the Kardashians or anyone else, but rather whether this society actually survives, and if so, what would it look like? There are also other problems with climate change, because as I said, it's a huge cluster of problems, not just a singular problem. There is the change of the climate in terms of our weather changes. We have droughts, we have too much rain, which impacts our food systems, but you also have health impacts of climate change. Tackling all of this in a great amount of detail is what our course Limits to Growth does. This is why I'm just putting out this slide here now as a teaser. You can also, for the first time, see the self-study star. You can look deeper into this, but this would just take way too much time. Trying to emphasize the point here, climate change, second challenge of the 21st century. It's not just about it's getting warmer, which is bad, but it also has like side effects on our health, and so on and so on. Nonetheless, we're not really doing much. There was a few years back, 6-7 years back, a quite surprisingly strong movement with the Friday for Future initiatives, Last Generation, Extinction Rebellion. Now I think it's a new generation, whatever they're calling themselves now. So there are quite a lot of people who actually went to the street, who did events, who tried to raise awareness, who tried to push changes. But especially in recent times, where we tend to go back to playing war games again, all of those efforts, or quite a lot of those efforts, somehow faded into the background. Nonetheless, just because we're back to war games now, all of this stuff did not stop. Like, we still have environmental pollutions, and wars are really not good when it comes to environmental pollution. They're also not really good when it comes to fostering climate change. They're also not really helpful when it comes to taking away the money that could go to protecting our future. But at the moment, we're ignoring it quite heavily. And just because we have other priorities at the moment doesn't mean that all of those problems suddenly stop. And as Greta nicely said it, change is coming whether you like it or not. So the climate change will be there, and then there will be changes, no matter how much we close our eyes and try to ignore the problem. So we talked about climate change, and that what we skipped so far is that we also need to adapt to a changing climate, which is, for the emerging technology students, going to be part of the 2 case study examples that we're going to do later. We're going to look into sustainable and resilient food production. How can we adapt there, and what kind of digital technologies can we use to make that happen? And then we're also going to look into biodiversity aspects. So how do we adapt? How can we monitor certain things? What can digital technologies do there? We also talked about environmental pollution briefly as a problem that we somehow need, or as a problem cluster that we need to tackle. And we also briefly touched up on the fact that we have a finite resource system, and that we're going to run out of certain resources at some point if we do not figure out how to deal with this problem. So sure, some resources are renewable, but we're also using most of those resources at a higher rate that they are regenerating, so we're also going to run out of those resources. Those are the 3 key challenges of the 21st century that we're going to tackle as part of this lecture series. And as I said, there will, of course, be more challenges that we also have to tackle on the site. And I'm not going to say that those are by priority the most relevant ones, and so on and so on. But if we do not figure out those problems, you don't have to really think about any other problems in the future. If we ignore those, then your future is gone. So do something. So what are we going to now? What are we going to do now after this really depressing start into this lecture series that was supposed to be a motivation? We can, of course, try to find ways to do something. What is quite famous or popular is to think of those problems, especially since it's related to climate change, in terms of CO2 emissions or your CO2 footprint. How can you try to reduce your own CO2 emissions by changing your behavior? So for example, if you take a flight from Hanover to New York, the flight emits, by burning fuel, emits CO2 emissions. The airplane needs to be somehow being built, which produces CO2 along the supply chain. It also causes environmental pollution. It also needs resources to construct the plane, the airport, and everything in between. So what kind of actions can you take to reduce your own footprint on the environment, either specifically tailored towards CO2 or your whole environmental footprint in general? And what usually pops up in the media is, hey, here's a CO2 footprint calculator, see how much CO2 you are emitting per year. Here are some tips what you can do. And that's actually not a bad idea to get a feeling on how much CO2 your own actions are causing. Are you someone who's just studying like a good student in their room, not doing everything on the side? Or are you someone who's taking a plane every other weekend to go skiing, go shopping in New York, then doing some hiking somewhere on Mallorca? You get the idea. So depending on how you already live, you have varying CO2 footprints. And companies also recognize that it's quite interesting from a marketing perspective to get this green image, to promise that using their products or buying their stuff will be good for the environment. So for example, Microsoft at some point promised to be carbon negative. So that means, or let's say first, let's finish the sentence. So that by 2030, they want to be carbon negative, and by 2050, they will have removed from the environment all the carbon, all the CO2 that the company has ever emitted, either directly or by electrical consumption, since it was founded in 1975. So carbon neutral would essentially mean all the CO2 that my actions are causing, I'm trying to somehow grab it back from the air and store it somewhere safe, or by somehow trying to figure out ways to get it out of the environment again. Carbon negative would mean Microsoft does not only make sure that it's not emitting any carbon anymore, but taking more carbon out of the environment than it actually emits. And then by 2050, to reach that goal, they would need to go back in time and collect all the other carbon that they emitted over the existence of their lifetime since 1975. This is utter bullshit, especially since the whole AI boom made this goal absolutely unrealistic to attain, and Microsoft is not even referring to this goal anymore. They acknowledged that given the AI boom, this is not feasible at all anymore, and now this goal is just gone. But Microsoft isn't really the only company who comes up with such kind of promises just to boost marketing, sales, brand recognition, or brand perception for a short while and then just ignoring those goals later on. They made several promises or similar promises like Microsoft, but in the end, they also practically abandoned it, even though they might have not officially admitted it that they don't care anymore, but they are also so far away from being something like carbon neutral, carbon negative, or even trying to reduce their carbon footprint in a meaningful way by 2030. So that goal is also gone. The electric car manufacturer Polestar once had this goal of producing a climate neutral car. They were embarking on a journey that they said is the most challenging that they had so far. So we're embarking on our greatest journey so far, challenging ourselves to create a climate neutral car by 2030 by reducing emissions through supply chain and production. So from getting the resources off the ground, transporting them to the manufacturing facility, building the car, putting that car into use. They wanted to make this whole experience climate neutral. However, they run into a problem that is quite easy to predict. Relying on the current trend of offsetting those carbon emissions by planting trees is not sustainable in the long run. It would mean using too much land, and the long-term carbon storage capacity of forests and soils is not well known. Offsetting by planting trees also risks contributing to monocultures and loss of biodiversity. Additionally, there can be no guarantee that a forest won't later be lodged, devastated by a forest fire, or altered by climate change. So this idea that you just plant a tree to make your bad behavior go away doesn't work. So for example, when you're buying an airplane ticket, you quite often get like an offer, hey, offset your carbon damage by paying $20 extra. First of all, those $20 extra don't cut it, or they're offering you to plant one tree to do it. That's also not going to cut it because you're emitting way more. That's the first fallacy there. The second fallacy is, if we're all trying to do this, we will need several planets to offset the carbon that we're just emitting on this planet, because there's just not enough space to plant that many trees. And even if we would have that space, so that was the second fallacy, then you would need to make sure that those trees remain where they are, and that you're not cutting them down to then burn them for heating purposes, or that they are burned down by a forest fire, because that would release then all the stored CO2 back into the environment, or that those trees die off due to climate change, because maybe it's getting too dry, too hot, too wet, whatever. So this idea of we're just planting ourselves out of the misery just doesn't work. At least Polestar recognized that, while Microsoft and Apple and a lot of other tech companies just ignored it. So CO2 being one of the problems, but it's not the only problem that we're having here. It's also how we as consumers who buy products from companies choose our products. For most people, speaking now maybe for the computer scientists or digital technology students, they tend to, for example, choose digital products based on hardware requirements or technical specifications. Like, do I get this tablet or this smartphone compared to another smartphone, or which notebook am I going to buy? Like, look at the technical specifications, decide what's the best fit for my money, or which fits best my requirements from a user experience perspective or from a technical perspective. Sure, there's probably also a little bit of brand stuff in there. Hey, I have the latest, newest iPhone or Pixel phone or whatever. What is often absolutely ignored is the idea or the question of how long does this product actually last, and what are the factors that contribute to making a product last very long. Like, what components are built into those products? Are they really meant to last 10 years, for example, for a smartphone component? Or are they meant to break after 2 or 3 years? And then if something breaks, how easy or hard is it to fix this? And some of you might know the company iFixit. They are repairing IT products, or they are selling you the equipment to prepare your stuff yourself. They're providing very detailed guides on how to do it at home. And they're also ranking IT products of major companies based on how easy it is to repair them, or how bad it is, and how bad the manufacturers make it on purpose, how difficult they make it on purpose, by, for example, gluing all the components together. If you glue the display into the smartphone, it is very, very hard, borderline impossible, to get the display out, to replace something, and then put it back in. There are also cases where replacing a certain sensor then bricked the whole hardware because it wasn't an original replacement part. Or they're developing screws for every new device so that you cannot open your device with a normal screwdriver. And so on and so on and so on. So why am I making this point? To further highlight this point that companies are promising you that using their products, using their services will help you personally to contribute to saving this planet, while it's actually not the case. So they make bold promises that they abandon as soon as it doesn't benefit their bottom line anymore, so they won't make a profit on it anymore. And in the back, they're making it actually hard to make their products last as long as possible to save resources, because this is not in their interest. They are making money by selling you stuff. But we'll get back to that as part of the circular economy. So those examples, just as an indicator, as some illustrations on where you are also personally obviously contributing by making certain decisions to resource consumption and pollution and so on and so on. So you're taking an airplane, you're using products, you're buying essentials for the everyday life. Everything has an impact on this planet. There are different online calculators, mostly quite simple tools that will help you to compute your own ecological footprint or your own CO2 footprint. I highly recommend it to just do it for the sake of getting a little bit of a feeling of how much you're actually in there, but it is not an exact science. You cannot really do this in an extremely detailed manner without spending hours on this. Anand will give a two-part lecture later in this lecture series on so-called life cycle assessments, where we're going to do explicitly detailed calculations of the impact of producing and using certain products or services, where you can do this. And if you would do this for every product and every service existing on this planet, then you could also do very detailed ecological footprint calculations for each and every citizen. But as you will see, this is a quite complex topic in itself. So we're going to wait until Anand's lecture on that topic. What is also quite interesting to know, where this idea of the carbon footprint actually comes from. Because you might assume, at least that was what I assumed, that this was like a tool created or a concept created by people who tried to first quantify their own impact on the environment and then do something to improve it, to be a good role model, to then inspire others to do something. However, that is not quite the case. There was once a nice tweet. The first step to reducing your emissions is to know where you stand. Find out your carbon footprint with our new calculator and share your pledge today. Posted by British Petroleum. Those people who are digging up dead dinosaur juice for a living, making billions of profits and ruining our planet. And blowing up oil rigs every now and then due to bad maintenance quality, but that's a different story. Good. So the idea of this carbon footprint and that you as an individual are supposed to fix this problem comes from one of the world's greatest environmental polluters on this planet that history has ever seen. If you look at the 100 companies, let's start the other way. You can compile a list of 100 companies, and those alone produced more than 70% of this of the world's greenhouse gas emissions between 1988 and 2017, so over a 30 years time period. And guess who is on that list? British fucking Petroleum, who as just a single company produced 1.5% of all greenhouse gas emissions in those 30 years. Just a single company. And the other rest of this list is not really surprising. Besides BP, it's essentially only companies that have something to do with fossil fuels, being it coal, being it oil, something that you can burn. Those is essentially the whole list down to the 12th or 15th position. I do not have the whole 100 companies in mind, but the tremendous amount goes back to essentially fossil fuel or mining operations somehow. Just China coal itself as a single entity goes for 14% of the greenhouse gas emissions, not counting the environmental pollution and environmental destruction and ecosystem damage they did with those mining operations. And those are the people who are telling you that you personally, you individually, have the responsibility to save this planet, not them. And I'm not saying that you do not have a personal responsibility to say something. Please don't get me wrong. Your decision to go on an airplane which flies with fuel provided by British Petroleum is your decision. And if you don't decide to do that, that is your individual decision that can benefit our planet and our future. However, blaming it only on individuals saying we are just providing the tools, the weapons, the products to kill this planet, it's not our fault that people are actually doing it, is also foolish. So, yeah. There are some things that are quite easy to say, okay, I'm just not going to do it anymore. I don't need to go on an airplane. I don't need to buy a new iPhone every year. There are certain sacrifices in quotation marks that are not really sacrifices in the first place. They're just choices to have a different lifestyle. Others might be more difficult to change. So if you're a student, for example, or actually it goes beyond students, like if you're, for example, renting an apartment, the main aspects or one of the main requirements for an apartment is obviously how much you can pay per month. And if your financial limitations just force you to take this category of apartments that are available that are very shitty insulated or have a really bad heating option, this is outside your reach. You just cannot change that. You also need to eat food to not die. You need a roof over your head, you need heating, you need water, you need a medical healthcare system. There are certain things that you cannot really live without. And just saying, oh, look, I got cancer, I'm just not going to the doctor because it's bad for the environment. Sure, your decision, but I'm not talking about those things. I'm talking about jumping on an airplane every other weekend, for example, or buying a new iPhone every other year. And I guess after this lecture series, I'm not going to get funded by Apple anymore because I'm making such great marketing for them. Other more borderline decisions might include those two idiots here on this photo. Those are my two dogs. Sure, you could argue you don't really need dogs. They need food, they eat meat. Is it really a necessary expense on this planet? Not from a financial perspective, but from an ecological perspective. Does this really have to happen? And for me, the answer is yes. I greatly benefit and it makes my life much, much better to have those two idiots in my life, but it's obviously like a more grayish area from the perspective of is this really necessary? And now we're moving into this territory from what is the absolute minimum that you need to survive towards what is a life that is worth living. And where do you cut, or where do you then draw the line in the sand to say, okay, this is a quality of life that is worth living, but not going into the excess. Do I need to be Jeff Bezos and put dick-shaped rockets into space to have a life worth living? Or is this maybe beyond what is necessary? So comparing now having dogs or having pets at home to improve your life quality versus do I need to go and see outer space just for fun? So this is now impacting your life personally, like how are you going to live your life? Some of you might actually have plans of getting children. At some days, some of you might actually already have children. And given what you have already learned today, that somewhere in this near soonish future of the next 70 years, we will probably face tremendous hardship and challenges if we do not start addressing them now. You might not only have to think about yourself, that you might have like 10 bad years before you die, but you also have a responsibility towards your children. And what are you going to tell them when they at some point ask you like, hey dad, hey mommy, this was known since at least the 1972, and if you look at our other limits to growth lectures, you will know it's like going back even further. Why did no one do something? Why did you not do something, because all of this is public knowledge. Like, you know that. You don't have to look or watch this lecture series to learn all of this. This is public knowledge. This has been communicated many times. We're just reiterating it for the sake of motivating what we're going to do later in the course. I'm not sure what my pointer is doing right now, but we're just going to ignore it. Now, let's draw to an end of this first part of the lecture series today, the motivation part. Why is it also relevant as part of this university? Because the University of Clausthal has this big overarching research topic of the circular economy, which we're going to talk about in the second half of this lecture and then next week as well. So this university has recognized, okay, we need to do something in the future to tackle those challenges and even more challenges. What is the research and the education necessary to achieve this? So this is essentially the overarching context for this course as part of this university study program. Now, that was a very depressing motivation. For those of you who have already listened to our Limits to Growth course, you will know that feeling. It's not really getting better, but now we're at least finished this part. And the point that I wanted to bring across in those first part of the series is there is a tremendous amount of problems that we need to tackle. Otherwise, there is no future worth living for you or future generations. We have to do something. And we want to now see in the rest of this lecture series, not just today, but until the end of the semester, what are parts where we can use digital technologies wisely to contribute to this goal of having a future. I'm not saying that digital technologies are the only means to do that. I'm not saying that the things that we're looking at are the only problems worth looking at. And I'm also not going to say that we have to throw concepts like the Internet of Things, AI, or whatever on every problem. We'll get to this point where we're going to discuss, is this actually worth the effort, the resources that we need to do that, given the benefits or the pros that we're getting out of this. This is also going to be an important part of this lecture series. But now, we're first going to look at the so-called linear economy and its deficits before we're going to move on to the so-called circular economy. What you can see here at the slides is the linear industrial economy, the industrial system that we are mostly relying on at the moment. First step is always getting resources, either harvesting them somewhere or extracting them from the environment in any other way. Then we use these resources to make them into products. We distribute those products globally, we sell them, and then from an industrial perspective, those products are gone. They are the problem of the user. They can use them, and once they're done, they just throw it away. There's also this short handle for the linear industrial economy, which essentially says, take resources, make it a product, then get rid of it. So selling it en masse, getting rid of it, you made your profit, everything else is not the problem of the companies anymore. There's also more formal definition provided here by Walter Stahel. There might be other definitions, or there are definitely other definitions, but I find this quite helpful. We do not expect you to learn those definitions by heart. You can also use other definitions as part of the examination later. For us, it's important that you get the gist of what the linear industrial economy is and that you can describe it in your own words. This is true for all the definitions that will later follow. You can either take the ones that we provide or being able at least to explain them in your own words. So Stahel defines the linear industrial economy as follows. Its objectives are to maintain value, not to create value added, to optimize stock management, not flows, and to increase the efficiency of using goods, not of producing goods. So what that essentially means is you're trying to produce as much shit as possible and sell it to as many people as possible. One really obvious aspect or problem of the linear industrial economy is waste management. Because take, make, dispose leaves you with a lot of other stuff left at the end of the cycle. So you take resources, you make them into a product, and you sell them. Then you're done from a company perspective. Apple has sold you an iPhone, they're done. They're not interested in getting that iPhone back. They're not interested in you getting that iPhone repaired because they make money by selling you the product. Primarily, now they're also making a lot of money with extra online services, but in the end, they don't want to get the physical stuff back from you. So once you are done using something, you as an individual have to take care of properly disposing it, of somehow getting this back into the system, or at least not causing any further damage. But there is no incentive at the moment and no thoughts putting into this in the context of the linear industrial economy from the perspective of what happens with resources that we once extracted after the use cycle is done. So if you now think back to this World 3 model, we're essentially using our large stock of resources, putting it in the industry sector, using it, and then it goes. That's it, it's done. We take new resources, put them through the cycle, new resources, and so on and so on. At some point, you're running out of resources and end up with a large pile of trash or environmental pollution. And we already established this cannot really go on forever. That is not a long-term viable option. And to illustrate this with a few examples, we brought you a few of our favorites with respect to how bad we're actually at managing the waste that we have. So one quite popular and often heavily discussed option is nuclear waste. On one hand, an interesting topic because it is quite dangerous to handle and it's not quite clear what to do with it. On the other hand, also because nuclear energy is often used as an example for, okay, this would give us more time if we would use more nuclear energy, or would actually solve our problems with respect to clean energy because it doesn't have any negative side effects. I'm not going to go down into this direction. We're solely focusing on what do we do with the waste afterwards, because it's a really nice example of how dumb we as a society handle some parts of our waste, or most of our waste actually. Because until the, 50s, 60s, 70s, one of the great ideas that we had with respect to nuclear waste is to put it into barrels, put those barrels on a ship, drive this ship somewhere into the ocean, and then just drop those barrels into the ocean. We also had the great idea to drop them into the ocean without having them in saltwater resistant barrels. So those barrels are not sealed and are rotting at the moment. We also decided that it's not really necessary to mark all the positions where we got rid of our nuclear waste. So there are large piles of nuclear waste in multiple parts of this planet that contains rotten, disintegrating barrels of nuclear waste, and we don't know anymore where they are. So that was one of the greatest ideas that we had. Admittedly, we also do not really have any better plans at the moment, because to the best of my knowledge, I think I last checked in autumn 2025, there is still no place on this whole planet where we have a long-term storage for highly nuclear waste. We have some storage places for low level nuclear waste that is like still emitting something, but it's not super dangerous. But for the highly dangerous, highly nuclear reactive waste, we have not a single place on this planet where to store them for a very, very long time in a safe manner. In Germany, they tried it. They decided for, I think, 2 locations, because we had East and West Germany back then. They dug some holes, put them in old mining operations, sealed them, and they noticed, oh shit, there's water leaking in there from somewhere, going through the nuclear waste and then going out somewhere else. And now they're trying to get this under control for many, many years. Doesn't work, but they're also not quite sure if they can get the nuclear waste back out. And in the meantime, 30 years later, we still do not have an alternative place where to put them. It's also maybe one of the reasons why they're not getting it out. I'm heavily simplifying this whole topic here to make this point that we're really bad at managing some of our most dangerous waste, and we still even don't have an idea what to do with it. We're proposing nuclear energy as a safe, future-oriented alternative to everything else, while not knowing what to do with this waste that comes out afterwards. There's also this argument that nuclear energy is among the cheapest forms, not only the most sustainable or the most green source of energy, but also the cheapest source of energy that we can have. We're not going to go into that discussion from a financial perspective because that's not my field of expertise and I do not want to go down that road. But let's look at it from the waste management perspective. Thus far, we had 2 generations who profited from this cheap nuclear energy and all its benefits. But there's quite a surprising number of generations that then have to deal with the waste that comes out of those nuclear reactors, with the stuff that we still don't know where to put. And it's not like we just have to put it somewhere for the next 10 or 20 years or even 100 years, that we just have to store it somewhere safe. Nope. 40,000 generations have to find a way to manage the waste that only 2 generations have created. And those 2 generations are not even comparable in terms of populations to our population today. So nuclear energy has its price, and we're ignoring really big parts of this price, not from an economic or financial perspective, but from the environmental perspective. And we're just closing our eyes and like, nah, not a problem. Another example, why and in what way we're really bad at managing waste, goes back to that plastic bottle here. We are really, really bad at also taking care of our normal household waste. Plastic being one of the most pressing examples here, because plastic in itself is a quite stable product, but over time it decomposes. It breaks down into small pieces, especially if it's exposed to UV light, but also other environmental factors. And it's not like plastic then just goes away. No, it just gets being decomposed in smaller pieces. You might have experienced it yourself, that if you have plastic that was exposed to UV light for a very long time, you can essentially break it with your hand, just splinters into a lot of small pieces. And those get smaller and smaller and smaller. This is where, for example, this idea of microplastic or even nanoplastic comes from. So plastic it doesn't go away, it just gets smaller and smaller. At some point you can't see it anymore. And there was a quite nice study in, when is it from, 2019, where they analyzed food and other stuff to see, okay, how much plastic, micro, nanoplastic is there actually in our environment? How much of this are we consuming? And they estimated that we're consuming about 2,000 tiny pieces of plastic every week, which is more or less a credit card every week. And we're talking about something 7 years ago. So by now it's probably even more, because we did not stop polluting the environment with plastic. More plastic was put into the environment, more plastic already broke down. Is essentially a cycle that would only stop if we stop putting plastic in the environment for quite a while. So enjoy your credit card of plastic that you're consuming every week, or if you put it in the annual comparison, then you're eating about 250 grams of plastic every year. And once again, by now probably more, because we're 7 years ahead into the future compared to that study. So we're really bad at this. And sure, we're trying to tackle this by collecting plastic. In Germany, you have this fund system that you can give your plastic bottles back. We have the yellow trash bin, which should grab most of the plastic waste. But even then, we're not quite that good when it comes to managing those waste that gets there. So when this study was created in 2016, there was an annual plastic production or plastic packaging production of 78 million tons. 32% of those 78 million tons that were produced were so-called leakage, which essentially means someone threw it somewhere in the environment or did not make it to any kind of waste management facility. So 1/3 goes straight to the environment. Another 40% goes to landfills, also the environment. Then we have small fractions of 14% which are incinerated, which essentially means we're just burning plastic and then putting it in the environment. So it goes also in the environment. And then there are 14% that only make it to recycling. Out of those 14%, another 4% go into process losses. So we have at least 86% or up to 90% of all the plastic packaging that is produced or was produced in 2013 that just goes straight to the environment. Then we have 8% left that goes to so-called cascaded recycling, which often then refers to having higher quality plastic, which you can recycle, but then only use in a lower plastic quality product. So it's a little bit of a more complex topic in itself, but essentially I might not be able to use this plastic bottle when I recycle it to make it into another plastic bottle. I would need to make it into a lower quality plastic thing. And then there is 2% closed loop recycling. So that means for those 78 million tons of plastic packaging that were produced in 2013, 98% had to come from virgin feedstock. Only 2% were recycled plastic that made it back into this loop. Only 2% out of 78 million tons. So even in those areas where we're supposedly doing something with quite some effort by trying to collect those trash back, even there it still doesn't really work that well. So this linear economy problem of having these heavy limitations of not being able to manage the waste is one of the biggest, or is the biggest issue with the linear economy that we have. Nice fun fact, in 2015 there will be more plastic than fish in the ocean. On one hand, there will be less fish because we're overfishing our oceans and we're heavily polluting them, and we're also putting more plastic there, so excellent. So I was now highlighting some downsides to certain attempts of recycling. It's not the only problem that we have a lot of leakage or that we're recycling with something that ends up with a lower quality product. It also has the issue that recycling often requires a lot of energy. So for example, I can recycle glass components quite nicely by just melting them again, but melting glass is extremely energy intensive. Same, for example, for aluminum. You can more or less indefinitely recycle aluminum, but it's extremely energy intensive. Some materials cannot be recycled at all, at least yet. So for example, those blades from wind farms are often piled up in a large place or large space because we just don't really know what to do with them yet. Doesn't mean that it's going to be a problem for forever, but there are some things that we cannot properly recycle. Then there are also impurity challenges, either because the material just consists of multiple inputs, but it can also be impurities from the pre-processing aspects. So for example, my smartphone consists of quite a lot of different inputs. Some just in very small amounts, you could even maybe call them trace amounts, because like how much raw materials or critical raw materials or rare earth materials are in there. It's like really small trace amounts. So when you are taking the smartphone apart, how do you get those out? Usually you shredder IT devices, cut them into very small pieces, and then you try to put them through different recycling stages. But if you do not make them fine enough, you will always have impurities. Or if you cut a certain piece right in the middle, you might still have like two different inputs glued together or melted together. So those impurities are quite challenging. It also often requires a lot of manual labor to sort through stuff, and recycling material is often with a lower quality than the input material. That is not true for everything. Like I said, aluminum, glass, more or less indefinitely recyclable, but plastic often has this problem that essentially you're cascading down a quality line. And it gives you also this false sense of safety by just throwing it into the trash bin. I did my thing, we're safe, everything is fine, I can just buy the next thing. I can easily get my new iPhone because I gave my other iPhone away to recycling, everything is fine. No, recycling is an extremely difficult, challenging, and resource-intensive process. Recycling is not going to save us, it's going to help us buy more time, because we're losing, hopefully, less resources than the alternative, which would just be to throw it into the ocean and then not having those resources anymore. But it's not the silver bullet that everyone is hoping for. That said, I am absolutely not saying you should stop recycling. I'm just highlighting here that recycling in itself has challenges, and we need to be aware of the fact that recycling is not the silver bullet. So please do not stop recycling. Recycling is great, but it's better to make sure that we do not have to recycle anything in the first place, so that products do not go to waste, that I use them for as long as possible, that I can repurpose them, that I can repair them, that I do not create any waste in the first place. So buying less is obviously like one way to do that. But sometimes you have to buy things, but then it should be something that more or less lasts forever. And I once read that somewhere in Asia, they considered waste as an inefficiency. Not sure if that is true, but maybe something that is more intuitive is putting this concept of waste into the organism of nature, of biological systems, because usually they don't know the concept of waste. In a biological nature cycle, there's rarely an example where waste actually exists, because everything that is somehow created will be then used or reused by someone else. There's rarely anything produced in a nature cycle, if you take humans out, that is not going to be repurposed somehow in a different cycle somehow else. So waste should be treated by us as a sign of inefficiency, of wastefulness, of something that needs to be optimized away or to be avoided at all costs, because waste means we lost something. If you go back to this World 3 model, waste is always something that means our resources are dropping, we're not getting them back. Waste needs to be avoided at all costs. And this is where we're going to end today, because the circular economy, which is trying to tackle primarily this waste problem, but also some other aspects, is our topic of next week. It's essentially trying to get rid of the negative aspects of the linear economy by introducing circularity. And yep, that's what we're going to talk about next week. Sorry for making this slightly longer than planned, but those few extra minutes are probably fine, especially since you had a very short lecture last week. Thank you very much for being here. We'll now cut the recording and take a 5-minute break. So we'll meet again 5 minutes before 4 p.m. for our Q&A session. Thank you all very much for being here, and see you in a second.